Hey everybody, Jeffrey Powers here, and I'm here with Alastair, and welcome to another Build Day TV. We are talking about AWS networking and load balancing. How you doing, Alastair?
I'm good, Jeffrey. I'm good today. It's beautiful autumnal day here in New Zealand.
And you said that there's going to be some filming happening there in New Zealand.
Yeah, made our national news, although the country is in lockdown and only New Zealand residents and citizens are allowed to arrive into the country. A team came through a couple of days ago to start work on Avatar 3 with Weta Workshops and Weta Digital.
Awesome. So we're gonna start seeing the next series of Avatar. You'll see it before we do, I guess, technically, unless it's all
I
locked
think
down.
it'll turn up at the same time in the US as it does in New Zealand.
Okay. All right. Well, hey, they actually use AWS as well as we do, but we're using it in different ways here. One of these things, they might be figuring out how to use load balancing on their AWS systems as well. So, with that said, Alistair, why don't you start us off on load balancing and what you're going to
Sure.
present today?
So we've already done two episodes looking at AWS networking. We looked first at how subnets work and public and private subnets and routing, and then we looked at firewalling and network access controllers for security. Next piece I want to look at is load balancing and using the idea that we can have a bunch of usually web servers behind a load balancer, and the load balancer is used to abstract out the detail of those web servers and hide it from whatever's connecting to them. So load balancing isn't something that's new, it's been around for a long time. And the objective is to have this single entry point and have all of the connections to some service or some website come through one place and then distribute that load out onto the back-end servers, and usually multiple back-end servers. Multiple might mean 2, it might mean 200, it might mean 2,000. And what we want to do is hide the details of what's in that back end behind this load balancer. So everybody who's connecting just sees a load balancer and connects in exactly the same way no matter what's going on behind. We do also talk about load balancers as being part of a decoupled application architecture. And it's that idea that you don't have to see inside the back end behind the load balancer to use the load balancer. So we'll see in later episodes, decoupling is a really important design idea on AWS.
Okay.
And the kind of benefits that we get in here are sometimes around scalability. So we could just have a single really big web server that hosts an application. But it's a lot more scalable. It's easier to scale a lot of small web servers. And remember on AWS, when you're running a web server, you're paying per hour for each web server. So you want to run just enough web servers for the current load and no more. And so that scalability of having multiple smaller web servers behind the load balancer and changing the numbers over time is important for us. There's another important aspect about availability. If I have a single web server and something goes wrong with that web server, then my entire website is gone. Well, one of the elements that we have on most load balancers is checking that the collection of web servers, each one is healthy behind the load balancer. And this is the availability idea of not sending traffic to a web server that's not working correctly. And this is, again, a function of the load balancer. And then finally, for a lot of use cases, we use a load balancer as part of our security architecture. Sometimes we use it to hide parts of the server behind, and we'll see that the application load balancer is really good for hiding and exposing different parts of a web server, because not all of the web server should be accessible from the internet. Also, there's an element of scalability of security where when we're under attack and when things are being compromised, we still want to be able to deliver a service. And so enabling scalability is part of our security structure. This is when we talk about the CIA triad for security, the confidentiality, integrity, and availability. And the availability part of security comes in here as well. So there's a lot of different load balancers around. Load balancing has been around for a very long time. And I just grabbed a few that I know about and grabbed some logos for them. And a variety of different vendors have these load balancers. The one we'll be spending our most time in is that purple icon in the middle for the AWS Elastic Load Balancer. But these load balancers get shipped in a number of different ways. So when I was first working with load balancers, they came as a physical appliance. Somebody would ship you a 1U or 4U server as the load balancer that you had bought. You'd install this in your data center, and it would sit alongside all of the other physical servers in your data center. Of course, virtualization came along, and so we would install the load balancing software inside a virtual machine. And it would function a lot like the physical appliance, but it was now inside a virtual machine. Of course, we don't really like to be managing installing software in virtual machines when it comes from third parties. So quite often the virtual appliance structure came up. So there was an image of a virtual machine with the load balancer already built in, and that's what we'd deploy, rather than deploying our own virtual machine and then installing the load balancer software. A lot of benefits around virtual appliances being hardened and secured and all of those kinds of things. But as we move to a lot more public cloud services, then load balancers as a managed service becomes important. Rather than having to worry about any of the implementation, support, and update details, actually just consuming a load balancer, programmatically deploying it, using it while we need it, and then disposing of it when we're done. This managed service idea is really useful for load balancers, and we see shifts along this. So a physical appliance might take weeks to arrive, and it might take you a couple of days to commission it. Software in a virtual machine might take hours to arrive and minutes to configure, and then virtual appliance is much the same. Managed services turn up in seconds and can be destroyed in seconds. And so the rate at which you can create and destroy things becomes much faster. Also really cool because then we can test things and play with products for much shorter periods in time, and particularly with managed services, just pay for the resources we're using while we're using these services. So I wanted to talk specifically about the AWS Elastic Load Balancer. That is the AWS managed service for a load balancer, and it lives inside your virtual private cloud. So it sits inside a subnet in your VPC, as we talked about in the last two videos. It has things like security groups on it, and it's subject to network access controllers for traffic and for routing tables as well. So all of the normal constructs of a virtual private cloud VPC work with this. But it's a fully managed load balancer. AWS looks after all of it. You do not have to think about EC2 instances to run it. You don't have to think about patching and updating. It is fully managed. Because it runs inside of VPC, it's a regional service. So that means that it runs across a group of availability zones in a single region. In the next video, we'll talk about multiple availability zones in regional, but I wanted to introduce Elastic Load Balancer before we talk about that. The Elastic Load Balancer has some pretty outstanding performance figures. Some of the tests that I've seen for a network load balancer talk about doing tens of millions of packets per second through a single network load balancer, and auto-scaling to tens and hundreds of gigabits of throughput. So these things are really high performance potentially. But they're very low cost because you pay for the resources you consume. You pay for runtime hours and you pay for traffic through these things. You don't pay a fixed upfront cost. You just pay for what you're using. So the cost is very much coupled to the value that's being delivered. Elastic load balancers are usually accessed just through a URL. Now, this is a little bit of a departure from what we see in normal load balancer deployments. Most often, load balancers have an IP address or a collection of IP addresses, and then we have a separate DNS service that points to them. For the Elastic Load Balancer, in almost every use, the thing that you access is just a URL, and the AWS software-defined network handles everything behind that. And so you can really think of the Elastic Load Balancer as just being another of the ways that we're programming the software-defined network that AWS is operating. And Elastic Load Balancers can sit in multiple parts of our infrastructure. We've already seen subnets that are private, that are not accessible from the internet, and subnets that are public, but are accessible. We have the same construct around for the Elastic Load Balancer. We can have load balancers that are used to allow public access into our application, that are the front door into the application. But you can also have Elastic Load Balancers that are used to separate out different layers or components in your application that are never accessible to the internet, that are purely internal. So it's quite a capable and flexible service.
Yeah, I agree. It's very straightforward too. So being able to set up,
we'll find there's always complexity underneath.
Yeah, but you can always set up for internal or external, and it looks like something that can easily be taken down and built back up without any problems.
Yeah, so like most AWS services, there are APIs for creating them. So you can use a PowerShell script or a Python piece of Python code or some Java code to create these, or you can use the AWS CLI to create load balancers. In the next video, I'll do some demos. We'll use the console because it's easy to see what's going on with the console, but I definitely have created load balancers using automation.
Okay.
So as we start looking at an elastic load balancer, AWS, as always, have their own words for talking about things. And so we need to define what those are. The first element of a load balancer is a listener. So the listener is the input side of the load balancer, and so it's accepting connections coming in. If it's a load balancer that works with HTTP requests and HTTPS, then there's two different listeners for that. One for HTTP, one for HTTPS. If it's a TCP-based load balancer, so it's load balancing incoming TCP connections, then there's one for every incoming TCP connection. So we absolutely often have multiple listeners. And particularly if we're doing TCP port load balancing, we can maybe be listening for 3 or 4 different ports that are being offered by our back-end service. So the listener is the front. And so, of course, then there's a back, and the back is called a target group. The target group is the group of web servers or application servers that are offering the service. And so there's a linkage between a listener and a target group. And most of the time, there is only one target group for a load balancer. And all of the traffic coming from the listeners goes to the single target group. But we're going to look at a thing called an application load balancer, an ALB. And with an ALB, you can have multiple target groups. This is a really powerful function for breaking your website up across multiple groups of web servers. So we'll have a play with that when we actually do a hands-on demo of this, and we'll use 2 different web servers to make up different parts of a single website. But listener is the front end, target group is the back end, and there is a connection between those two. A really important aspect of a load balancer is to make sure that the things behind the load balancer are working correctly. And so we have these things called health checks, where the load balancer goes out and checks the members of the target group and says, is it still working correctly? If it's a TCP port-based load balancer, then it's just checking to see that it can open the TCP port, that the TCP port is ready to accept connections. And with TCP-based load balancers, that's as deep as it goes. There's no way of validating the actual servers behind that TCP port is working. But if we're working with HTTP and HTTPS requests, we can actually specify a separate URL, a separate path inside our website that will return a 200 OK, the normal everything's good message if things are working, and that we've written to return errors if things aren't working correctly. So for HTTP health checks, we can do end-to-end validation, and we normally write a custom health check URL. So if it's a PHP site, there might be a healthcheck.php file that actively goes out and checks that the dependencies for the application are okay. It could be things like making sure that we can talk to the database server and we've got enough free space on the file system. It can be making sure that we validate that the installed version of the application matches what's on some software distribution location, those kinds of things. But these health checks on a website are normally custom written and check a series of dependencies for application. Now, there's usually a compromise here, because the more work you do for the health check, the more resources you're using that aren't delivering your application. So there's usually a trade-off somewhere about how comprehensive a health check you do and how much health checking you do elsewhere. Like making sure that the database server is still operational is probably not the most important thing to have in your health checks. Just making sure that the web server can talk to the database is usually enough. You usually do something else to monitor the database behind. But this is to make sure that a particular web server is still functional and is delivering the service through. So the first of the types of load balancer that we work with the elastic load balancer. The elastic load balancer used to just have one kind of load balancer behind it. It's now got 3. The easiest one to understand is the network load balancer. It accepts TCP connections, so 1 or more incoming TCP ports. It simply then forwards the request on to one target group. So it'll send a particular request to one member of the target group. and it doesn't do any inspection or looking at what's going on with the TCP connection. All it says is there's an incoming connection, I'm going to forward it to a back-end server, and then the traffic is going to flow between the client and the back-end server. It's really fast. Network load balancer is the fastest load balancer AWS has. So tens of gigabits per second. I've seen some benchmarking that says that in normal load, the network load balancer has headroom for an immediate step up in requests of 1.5 million requests per second. And it'll scale to tens of millions of requests per second. And then when things have evened out at maybe 12,000 requests per second, there's again 1.5 million requests per second worth of headroom. This is pretty seriously high performance. But it's not particularly smart because it just takes an incoming connection and forwards it to a back-end server that has an open port. Can't do sophisticated health checks. We can't do a lot of status checking in, but it's ridiculously high performance. Network load balancer is sometimes used in front of web servers because they're so high performance. You can absolutely say, I want to forward TCP port 443 for HTTPS and port 80 for HTTP through to this bunch of web servers. But sometimes we want a little different load balancing, and particularly we want some awareness of HTTP and HTTPS requests. And there is this thing called the classic load balancer. The classic load balancer predates the network load balancer and the next one we're going to look at, which is the application load balancer. This is the old load balancer. In fact, this thing has been around so long that it predates the virtual private cloud, VPC networking that we've been looking at in the last 2 slides. This predates having that centralized networking. Classic load balancer will accept either TCP port connections like the network load balancer or HTTP requests. And if we want to use HTTPS, so secure sockets, we can put a web server certificate on the classic load balancer and it can receive incoming HTTPS requests as well. So we can have the load balancer handle all the HTTPS traffic. The classic load balancer is steadily being deprecated, so AWS would like us to move away from it. In fact, there's a wizard to move from the classic load balancer onwards to either the Elastic or the application load balancer. But it's a really low-cost load balancer and it's been around for a very long period of time. It's very simple. And then there is the application load balancer. So this is our most capable load balancer, but it's an application-specific load balancer. It takes HTTP and HTTPS requests. And this is the only one of the load balancers that can have multiple target groups to send traffic to. We'll see that you can set routing rules up on these targets and say, it's a web request. If it requests from this path in my website, send it to this group of web servers, this target group. If it's in a different path in my website, send it to a different group of web servers. And this works with some of the microservices architectures where your website is actually made up of a series of small units of compute, each of which runs on maybe a bunch of EC2 instances, but maybe a bunch of Docker containers or a bunch of Lambda functions as being each of the microservices. Like the classic load balancer, if we've got HTTPS connections coming in, the application load balancer can do the SSL for us. So rather than having our web server at the back end do the SSL work, we can have the application load balancer do the SSL. If we are going to listen for HTTPS requests with the application load balancer, we do have to put a web server certificate on it in order for it to look inside the requests. So the application load balancer is our most smart and it's our most intelligent load balancer. So a summary around the Elastic Load Balancer. It is a fully managed regional service. You don't need to worry about scaling and about availability for the Elastic Load Balancer. That's managed by AWS. There are no software updates. You're always running the newest version. It can be used for public access or internally within your application, between parts of your application inside your VPC. The Network Load Balancer, layer 3 TCP connections. So we can just load balance TCP connections. It doesn't have to be a web server, although we can use this to provide access to a web server. We have an application load balancer up at layer 7 where it knows about the HTTPS requests and HTTP requests. It can look inside the HTTP requests and make decisions based on the contents of the request. We have our legacy load balancer classic. We're being steadily moved away from, but provides us a very low cost option for load balancing on AWS. And always our load balancers are accessed through a URL, through an actual DNS name path, rather than directly through an IP address. Sometimes there's an option for an IP address, but usually it's through a URL. So Jeffrey, load balancers, does it seem a little less simple than it did just at the beginning?
There is some complexity. It's actually very straightforward. So once you get into it, it's probably going to get even more complex. But it's very flexible. It's you can bring it in and bring it out whenever you need to. You can put it in whatever layer you need it to be in, and use it for however you need to use it. And I think that's a really nice function for your systems there.
And what I quite like about it is that the complexity in here is usually related to your application. So if it needs complexity, it's because you have a complex application.
Yeah.
But if you have a simple application, you don't need to worry about lots of complexity. The complexity of running a load balancer isn't your problem, it's AWS's problem. So the complexity of using a load balancer with your application is all you have to think about. And this is why a managed service is so useful for us.
Yeah, and it's also regional. So if you don't want people in another area using certain parts, you can do that.
The definition for regional, and I know I haven't talked about what regional means in AWS. The definition for a regional service is that if there is a data center failure within AWS, the service will continue to operate. So regional in this sense means that it's highly available across a relatively small geographic area. The regional you're talking about is controlling where the load balancer can be accessed from.
Okay.
That's actually in a different service. That's in a service called the Web Application Firewall. And often the Web Application Firewall is used with in front of the Elastic Load Balancer to protect against maybe hostile traffic coming from places that are unfriendly to us.
Yeah, that makes more sense than putting it in the ELB, that's for sure. So, but yeah,
the earlier you can block it, the better.
Yeah. So in this case, it's more like if node A is down, then node B will be able to pick up and deliver what you need.
Yes, yes. And when we look at using multiple availability zones in the next video, that regional focus will really become very obvious why I've called out regional in here.
All right. Oh yeah, like I said, it's pretty straightforward. So now let's delve in and figure out how it's all set up. And
yeah, let's close out this video and then we'll do the hands-on video next. So stay tuned for our next video where we go hands-on and build all three of these Elastic load balancers and take a look at what's required to configure them and how they operate differently.
And that has been the load balancing episode 3, technically 3A, so stick around for the next one. Go ahead and like, subscribe, and comment down below if you have any questions. We will be answering those questions in a later video. Alastair, thank you very much, and we'll see you at the next video.
Thanks, Jeffrey.